In this video, we're going to solve some linear equations. Those linear equations are going to model the scenarios that are used in these word problems. So in the first problem here, we have the price of a car. I'll call that P of T, since time is what's changing. And today the price is $11,730. Let's go ahead and put that in for readability with time changing here, which is what I put T, and it is going to increase at a constant rate. So it's going to increase constant rate of $1,125 per year. P of T is in dollars. T is years. So we want to find P of 3.2. It's going to be 11,730 plus 1125 times 3.2. 1125 times 3.2 is 3,600. And then we're going to add that to the base price of 11,730. And we get 15,330. Let me show you how to do that pretty easily in your TI 84 calculator. It's pretty nifty. Get rid of this calculus I was doing here. So when we go into y equals, we can make our function here 11,730 plus 1125, and we have to use the variable x. That's our only variable that we have in function mode. We're going to quit. We can go out to our vars menu, y vars. We're in function mode, and we just put our function in y1, and we can use this function notation here to open a set of parentheses and say I want my x to have a value of 3.2, and it will calculate it, and there's my $15,330. So you can use your calculator to quickly evaluate a function at one or several different points. We'll go ahead and do that sometimes here just to help with this. So let me switch up the way my screen looks so you can see my calculator and see the problems. All right, there we go. And now I'm going to model problem number 2 and solve it here. So Normaltown High School's pool record for the 100-yard freestyle was 46.7 in 1990. Assume that the record falls at a constant rate of 0.07 of a second per year. T is equal to the number of years since 1990. And this is R of t, where r is the record, right? Now I've got to figure out how many years have passed since 1990 and 2017. So 2017 minus 1990 is 27 years. So we want to find what the record is going to be now in 2017. So we're going to put in 46.7 minus 0.07 times 27 is 44.81. This is a good moment probably to talk about how such models are good around the original time that you made the model. They're good for a little bit of time, but when you go too far away from them, you're less certain of your answer. We'll talk about that a little bit more with some statistics things soon. But if I graphed this, let me just go ahead and graph this model, you'll see that it leads to something absurd eventually. So 46.7 minus 0.07x. I'm gonna zoom 0 here. So first thing is the model takes into account this idea of negative time, which doesn't really exist, but we could project backwards and we could say, okay, if this is what happened in 1990 when t equals 0, what was it back in 1980? And we could go 10 years into the past that way. But if I zoom out here just a little bit more, you're going to see that eventually it crosses the x-axis down here and that the record would start to get negative. That doesn't make any sense. So we also know that there's just going to be some point where this curve is going to level, where this is going to be a curve that's going to level off, and is people are going to get better, but they're going to get better and better by smaller and smaller amounts. They're not just going to keep getting better and better by this constant amount to where it takes them no time at all to swim 100 yards, right? That's not possible. They're not going to get infinite speed. So this is just an easy way to model things, and we model complicated things that have lots of curves in them. If we zoom in really close, we model them with a line, but that line is really only good when we zoom in real close to that small area that we're dealing with. The cost of renting a car is a flat $26 plus an additional 13 cents per mile. I'm going to use M for miles that you drive. How far can you drive for $99? So I'm going to set this function equal to 99. I'm going to say that I'm going to subtract 26 from both sides. 0.13 m is equal to 73. 73 divided by 0.13 and equals 561.538, blah, 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 blah. I assume that we're going to talk about whole numbers of miles that we can drive. So I'm going to have to round down here because I can't get to the 562nd mile. I don't have enough money to pay for it. So even though that's a 0.5, I'm going to have to round down because of the context of the problem to 561 miles. Okay. You can rent time on computers at a local copy center for a $7 setup charge, plus an additional $4 every 10 minutes. So, let's say X divided by 10. Sure, let's do it like that. So let's figure out if we are getting charged $4 every 10 minutes. That means that we're getting charged 40 cents a minute. So let's write it that way. So we have X is equal to the number of minutes. Now they're actually charging you in 10-minute rates, but we're just going to pretend that they charge you per minute. So how much time can you get for $24? $17 divided by 0.4. We should be able to get about 40 minutes, right? Because we have to go in increments of 10. We can't buy that block that gets us from 41 minutes to 50 minutes. Since we're buying in blocks of 10, we have to stay at or below 40 minutes. Purchase a motorcycle for $79.80, or you can lease it for a down payment of $573 plus $212 per month. Find an equation that describes how the cost of the lease depends on time. We did that. How long can you lease the motorcycle before you have paid more than the purchase price? So we're going to set this equal to $79.80 and solve. Let's just check that, make sure that I did that right in my head. $79.80 minus $573 is $74.07, and we're going to divide that by 212. We're going to get the X is equal to 34.9. It's just about 35 months here. So you could, on the 35th month, the lease price would exceed the buy price. Okay. The Math Club plans to pay a visitor $74 to speak at a fundraiser. Tickets will be sold for $5 each. Find the equation that gives the profit or loss. So they're going to have to pay a fixed $74. Then from that, well, let's write it the other way. They're paying $74 out of their pocket. This is big P profit. Plus they make revenue of $5 per ticket that they sell. How many people must attend for the club to break even? Remember that we have to sell a whole number of tickets. We can't sell a fraction of a ticket here. So 5x equals 74. So x is going to be 1, 4, and 4/5. So we need to always round up in this situation because we need to sell the next ticket to make enough to pay for the cost of the speaker completely. So we need to round up to 15. We need to sell 15 tickets. This will be our last one for this video. In the town of Oak Forest, a local 3% sales tax and a 5% state's tax are charged on all retail sales. Let P be the before tax amount, the subtotal of a purchase in dollars. Let T be the after tax amount of the purchase. So T of X, T of P. Sorry. Equals. So we're going to have a total of 8% tax that's charged, and we have to pay 100% of the original price as well. So we want to find the total price of something that originally cost $49. So 108% of $49 is 52.92, and that makes sense as a decimal because we can have dollars and cents. We can go to the second decimal place in the context of this problem. All right, that's it for this video. We'll come back next time and do some more of these problems. So this is just part 1. We'll come back and do some more solving of word problems with linear equations next time.